Okay, so I was thinking about yesterday in our discussion about the bowling balls. Do you remember that?
Yeah.
Okay, good. Sometimes I can't remember when that happened, so I'm glad it was yesterday. And we were drawing the force diagram, and you remember there was a discussion about the length of the arrows? So I thought maybe today we would do some fun stuff. Fun?
Fun?
Fun on a Friday?
What the fun?
It doesn't get better than that, right? Okay. And I thought what we would do is see if we can figure out really if there's any connection to the length of those arrows. See, they think it sounds like fun too. Now, I will say that the 7th period class yesterday, they really had strong opinions about the length of those arrows and what that meant. So I imagine you guys have some of the same strong opinions. You just didn't share them, and that's okay. But I think it's really important for us to figure out if we can make a connection there. Right? Okay. So what are factors that might affect how the force of the earth is acting on an object? Think about it for a minute. Okay? So let me get my cards here. Oh. Let me get my cards and let's see what we come up with. And I'm sorry guys, I gotta turn this other light on because I can't, it messes with me. Okay, that's better. So, Lane, can you give me a factor that you think might affect the force of the earth acting on an object? Need another minute? Okay, we'll come back to you. How about Sadie? Mass? Can the mass of what? Mass of the object, the mass of the earth, the mass of the object. So I guess if we're gonna change and measure things, these should probably be characteristics of the object. Okay? Yeah, because Earth isn't gonna change. Maybe. I'm gonna say it's probably not gonna change today. It hasn't changed in the last week, so we should be probably okay.
It hasn't changed in the last few million years. Maybe a few inches on the tectonic plates, but that's it.
Maybe, yeah. So mass. Let's see who has another one. Brianna? The type of object. What do you mean type of object? Like where it's at? Can you explain that a little bit more? Where it's at, like in this room versus in the hallway, or what do you mean by that? Yeah, like in different areas of like the building? Okay. Location, how about that? And I'm gonna put in the building because I can't let you go home to see until 2:50. Okay? Kennedy, can you think of something?
Maybe like the weight of the object.
The weight? Alright. I I guess I didn't plan this very well, I should have put that up higher. So I'm gonna kind of spread out my stuff. Jaden, can you think of something? We're just brainstorming here, so don't be worried about what you're gonna say, or there's no pressure. You don't know? All right. Well, maybe we'll come back to you too. I haven't forgotten about Lane. Dallas, how about you? Need another minute? Okay. Xander?
If that object is on another object, or if it's just on the ground.
Ooh, that's a good one. How do we want to word that up here? The surroundings? Okay. Now, I feel like you had two things in there, right? If it was, because, like, I can put my folders here on the ground, but they're still interacting with each other. So I feel like there were two things in there. So let's, can we refine that a little bit? Is there a difference between this and this and this? What's the difference?
Higher.
The height? Okay, are we okay with putting height up here?
Elevation.
Height/elevation? And then the other thing that you were talking about was like the objects like grouped together? Okay. Anybody else have anything? Huh?
The resistance of the object away from Earth.
No resistance. Say that again for me.
The resistance of the object away from the Earth.
So can you explain to me what you mean by that?
Like if the object is going up, the Earth has to pull down harder.
Okay, so like if the object is moving up, like if we throw a ball up? Okay. Madison, did you have your hand up?
Yeah, maybe the shape of an object.
Ooh. Do you guys think the shape of an object can have an impact?
Yes.
Okay. Jade?
Density?
Density? Okay. Yeah?
Material.
Material? Do you think the material that the object is made of, is that what you mean? Okay. Material. Lena?
Whether it's in like water or something.
Ooh. That's kind of like this one, right? Can I put that with this one? In water or
I would have said
Liquid.
Liquid substance.
environment.
can I put like in piles, Sandra? Is that okay? Like these are a pile, yeah? Okay. Anybody have anything else? Okay. I mean, I think this is a pretty good list. I think this is a pretty good list. Now, which way does the Earth pull?
Down.
Down. All right. And we're looking at what factors are going to affect how the Earth pulls down. So, you know, this is a physics class, so we've got to be able to change and measure it in a very orderly way. If we can change it, we call that systematic change. If we can change it in a systematic way and measure it, then what can we do with that information? We're going to collect some data. Then what do we do with our data? We're going to graph it. And when we graph data, we're going to make a graph that's a scatter plot. And what are we going to put on our scatter plot? Best fit line. And then what are we going to do for that best fit line? Find the slope and write the equation. See? Isn't that amazing? You guys know all the answers. Okay, and make sure that we can change and measure it in a way that's gonna allow us to collect data. Okay? So, let's start here. Can we change and measure the mass of an object?
Change or
You can measure it, but you can't change the mass.
We can measure it, but we can't change the mass of a single object. But could we compare the masses of different objects? Okay, so I'm gonna circle this one, and I'm gonna put a star next to it, because that's a little different than what we've talked about here. So maybe we need to expand our experiment a little bit. Can we systematically change and measure the location in the building? How do we measure a location?
We put it on a map.
Well, I mean, we're just talking about the school. How do we measure it?
You could start at one point and then you can change it and measure the distance between it.
Okay, but does that tell us anything about the object? Remember, we want to collect data that we can graph. Can we graph different locations in the building? No. So are we okay if I mark this one off? I'm happy to let you try and collect data as much as you want. But remember, all the data you collect, you have to graph. So are we okay if I cross this one off? Okay. And I'm not saying that it's not a good idea. I'm just saying that within the confines of this lab, maybe this isn't the best place for it. Okay? But don't you worry, we're gonna come back to that one in another unit. Can we change and measure the weight of the object?
Measure it.
No, it's singular.
Weight-
Like
weight-
mass, not
weight
like
isn't
singular
that.
objects, but we can compare masses of different objects.
The weight's more like a unit.
You could add weight onto it, but that's like not the same object.
Okay. So I'm gonna make the executive decision that I'm gonna cross off the word weight, because that is, that's a physics word. And I'm not sure that we really know what it is yet.
Weight's kind of like how much pulls on an object, and how much is, depending on the mass.
Let's look at shape. Can we change and measure the shape?
No.
You can change it, but not sure you can measure it.
You can't really.
So here's my object. Can I measure its shape? How? Okay, well, I mean, I can measure its diameter, but is that measuring its shape? I can calculate its volume, that's not measuring. Right, that's calculating. But can I find objects that are not in this shape that have the same volume? Yeah. I can change the shape by doing this. But can I measure it? How, what would we measure? Measuring what? The length? But we're not measuring length, we're talking about shape, right? We can measure things about this marker, but how do you measure shape? Do you see what I mean? Shapes are things like circles and triangles and cylinders. Can we change an object's shape? No. And then how do we measure it? Well, I mean, we can change it sometimes. Like if I have Play-Doh, I can change the shape of my Play-Doh. But how do we measure shape? You can measure aspects of shape, but you can't measure shape. It's not a number kind of piece of data. How do you make a graph of shape?
Yeah, you can measure the dimensions of it, but you can't really measure it.
Right, so I'm gonna cross this one off. I feel like we're a little confused about that one. if you really wanna know, or if you really wanna measure shape, then come see me and we'll talk about how you're gonna do it and then I'll let you try. Okay? Let's talk about density. Can we change and measure the density of an object? You can measure density.
We wouldn't be able to use the same object, but we could, do two different objects with about the same like, volume or something, and then measure the density of each object.
Okay. You actually cannot measure density. Density is a calculated value. We don't have a density meter. Like that's not a real thing, right? We measure things, then we use that information to calculate density. So what do we want to do with this one? Leave it, cross it, what do you want to do? Cross it off? I mean, if you really want to measure it, I'll be happy to let you measure it. You gotta tell me.
Cross it over.
I'm hearing from like 3 people. Let's vote. Measure it. Daisy wants to measure it, I guess we're measuring it. Cross it off. Alright. I mean, seriously guys, if you really wanna measure it, I'll let you measure it. I'm not gonna, the only one I made the executive decision for is weight.
Pretty sure you can't measure insides.
What about material?
You can't measure it, but you can change it.
Okay,
Can't really change it if you compare it to other materials.
okay.
It's not a numbering thing, like you said with shape, it's not a numbering.
It's more of a variable instead of a unit. You can't really measure.
Alright. So let's vote again, because I feel like more of you were willing to vote than put yourself out there and tell me what's going on with that one. How many of you wanna measure it? Chirp, 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 chirp. How many of you wanna cross it off? Okay. Alright, let's do resistance of the object away from the earth. So, Simon, you said this was like if we threw a ball up? Okay, so can we change and measure the resistance of the object away from the earth?
Kinda?
Yeah.
I don't know how you would measure that,
How far away it is.
You could throw it up and see how
Draw
high
a
it
different
goes.
object.
So we're talking about height, we've already got height here. We haven't talked about that one yet, so do you wanna come back to this one?
Yeah.
Alright, let's talk about height before we talk about that one. Can we change and measure the height of or elevation of an object? Yes, we can do that? Okay, do you wanna measure it? 2 people, 3 people, 4, 5? Yeah. Okay, how many of you wanna cross it off? Okay, I guess I'm gonna circle that one. Alright, let's go back here to resistance of the object from the earth. What do you think?
Yeah.
I mean, you can measure the force in which you would throw a ball up, so I guess.
How do you measure force?
I have no idea, but you can probably do it.
Of course, it's just a push or a pull.
Yeah, you wanna use my broom to measure it?
You can measure it with your scale,
What kind of scale?
like any kind, cause like, I don't know. I feel like someone would explain it.
Okay.
Measure how
The
fast
resistance
the
Probably
would be
calculate it.
applied to the weight, wouldn't it? Like,
I'm not sure, and remember I crossed off weight. Ethan?
Like if I take a tennis ball and I drop it and it falls on a scale, but if I take a tennis ball and I throw it and I throw it on the scale, it's gonna be more. So
Well, I can't let you throw things on my scales, cause that'll break them. If we had bathroom scales, that would be different, we could do that with a bathroom scale. Did anybody bring theirs to school today?
Unfortunately, a bathroom scale.
no, but I can walk home and get it, I'm walking.
I'm not allowed to let you leave until 2:50.
I could say I'm going out to my car and just walk.
No,
My
because
mom
you have
works
to have a
second
deputy.
shift, I can have her bring it.
Well, we're gonna need more than one. I didn't bring my bathroom scale to work either, so that's
Oh, but
an interesting way to do it, but we don't have the tools to do it. Okay? Simon?
You can time how hot, like, when you throw it up, you can time how, like, fast it comes down.
If we throw it up and we time how fast it comes down, do you think there will be other factors that affect it besides this? How fast it comes down?
Its weight, will mass or weight can affect it.
Well, remember, I crossed off that word weight, so maybe we shouldn't use that right now.
So it's mass, density, if you throw up a feather, it's not gonna go anywhere for a while, cause it's just like floating down, but if you throw up a bowling ball, it's gonna like speed down.
So there are different things going on there too, right? Because that's not just a difference in mass, that's also a difference in shape. So maybe maybe this one's
That's where we get into aerodynamics.
hairy, right? Maybe this one's hairy. So let's vote. How many of you want to measure this? How many of you want to cross it off?
That gets into drag and all that good stuff. Air resistance.
So Simon, we're gonna cross this off, okay? All right. The class has spoken.
Not rocket science yet.
I feel like Simon's secretly planning your deaths now.
It'll be fine. You're gonna have plenty of stuff to measure. Now remember, all the data you collect, you have to graph and be able to discuss when we discuss this. All right, so then the last one we have here is the objects, how they're grouped. And we talked about in water versus like in the air, and then in piles. What do you think about this one?
That's not numbery stuff, that's category.
I think we should cross it off.
Yeah.
Less stuff.
I'm just saying.
Lines are being drawn.
I feel like Xander's about to like
We can't
sacrifice
measure that with a number and a unit, but we can categorize it, yes, but we could also categorize shape and material and stuff like that, which we have already crossed off.
Okay.
And I'm thinking we don't wanna graph that much stuff.
Yeah.
So cross it off.
Now, is that the right way to think about it?
Yes.
We don't wanna make the graph, so we're gonna
Yes.
cross off as much as we
Cross off
can.
everything, no factors.
Well, if that's the case, then Mrs. Foley's gonna determine that you have to do this all. We just won't have this
Oh, wait,
discussion
no.
anymore.
No!
Yeah, Rachel?
Let's take
You
a
just don't
vote.
want this one.
Yeah.
All right, let's vote on this one. How the objects are grouped in water and piles, that kind of idea. How many of you wanna cross it off? How many of you wanna measure it?
Xander, come
Maybe
on.
we'll-
I'm sorry, Xander, it's the class rule. Now, I will say, like I said, if you really wanna measure these ones, some of these ones that we've crossed off, that's fine. But I want you to do the ones that we as a class have decided we're going to do first. And then just come and see me and we'll talk about how you're gonna do it and then we'll see what we can do, okay? But our tools are limited. Our tools are limited, so we have to be very aware of what we have to measure things, okay? Now, let's talk about the two we have here. What factors might affect the force of the earth acting on an object? Let's talk about height and elevation first. How would we measure this? Elena?
Just take out a
Like-
meter stick.
Get a meter stick and then hold a ball to like multiple objects to the same height and drop one and see how long.
Okay. So that kind of goes back to what we were talking about here. Are there other factors that might affect how long it takes for it to fall?
Yeah, so we
Yeah,
could
I
use
know.
one object multiple times. Or throughout the
For
whole
different
experiment.
heights.
Like different.
That should be a constant.
Okay. But then, what are we really measuring?
But then the mass.
Are we measuring how the height affects the force of the earth? Or are we measuring how time is affected by height?
I don't even
And
know.
mass.
I just crossed it off.
It's hard to,
We circled it. It can't be crossed off now.
Do a circle cross.
it's hard
We
to
can't.
calculate the force of the earth because it's kind
That
of.
one's
like
a
hard to do
no-go,
that.
just do that.
Can we take it back?
We're not talking about things we're calculating, right? We crossed off density because that's a calculation. We're talking about things we can measure. We can measure this. Right?
But how do we measure the force of the earth?
Oh, there's the question I was looking for. So, we have my brooms, right? Those are not very sensitive, but they are a forceometer, forcemeter if you're from Canada. They are, right? They can indicate forces. They're just not real sensitive and they don't give us numbers. But lucky for you, I was digging around in my spare room at home and I found this container of forceometers.
You have a spare room at home just full of stuff for science.
Oh, you have no idea.
Like
Oh,
I'm like a junk
rooms you have in
room.
your house?
You like a junk room?
Maybe. Okay, so these have more sensitivity to them. And we can measure forces. Okay? So let's talk for just a moment. Our variable is force, right? Our variable is force. We give it a capital F. And the unit is the Newton. The abbreviation for a Newton is a capital N. You cannot use a lowercase n, that means something else. You have to use a capital N. So we can measure the force acting on an object using one of these forceometers. You have to make sure that you are using the side that has the N at the top. The other side measures something different. We haven't talked about it yet. But the side with the N is the side you want to use. Okay? Now, there obviously is a spring in there. You can see it. But please be careful that you do not deform the spring because then that makes this useless. So I don't want to see people that are just pulling on it and playing with it. This is really just to measure forces. Okay? So we can measure forces. Can we measure height?
Yes.
Now let's go back to who said if we use the same object. Natalie, was that you? Madison? So if you use the same object, what are you going to change? The height. So is that your independent or dependent variable? Independent. Okay? So, mass.
We can measure mass. We did it with the spaghetti.
We can, but the nature of the experiment is different. Right? For this one, you're going to measure the force as you change the height. Right?
I don't think we need that one right now.
Of the same object.
The mass isn't changing.
But the mass, we can't change the mass of a single object without changing other things about the object.
So we don't need it right now.
But we can compare different objects with different masses. What has to be held constant?
The height.
Height. Height has to be held constant. So we have to measure it at the same place. Now, lucky for you guys, this room, the walls are made of bricks, right? So hopefully, if I go around my room, let's say I measure, I don't know, right here. Maybe my group is working right here. What if I measured it at this point in the wall every single time? Is that the same height? Yeah, so I can measure that height and I can say that my height is constant at whatever this is. And then I can just hold it up there every single time and just change the different objects. See how that works? Okay. I think that's enough information to make you dangerous, right? What objects are you going to use?
Maybe like a baseball, I don't know.
Pencils? Headphones?
I feel like we should do something with like a bit more mass.
An eraser?
A book.
A book? A highlighter? A muffler? I mean, if you carry it around with you. A bowling ball. Nobody's allowed to touch my bowling ball. Pen and a pencil? So are we getting the idea here? Here's the issue. I would like for you to measure as much of the stuff that's yours as you possibly can without breaking my force meters. Because if you start touching all the stuff in my room, what do I have to do? And I've gotta spray it all down. And I do spray down, like, the bucket that has the rags in it, I spray that down. The calculators and the rulers, I spray those down. But I would really rather not have to open every cabinet and spray down everything that's in there. I do not want you in the drawers or cabinets in this room. There are things in there that are sensitive, and I don't want you to touch any of that stuff. But if there's something that's sitting out, a tissue box. Don't touch Dummy, my plant. Don't touch Dummy. Yeah, well, he's a very special plant. But pretty much everything else, as long as it's reasonable, I'm okay with, okay? Just be respectful. Now, I want you to work in table groups, okay? So, you guys are a table group today. But I want you to collect your data. What time is this class over? 14. Ooh. So we're gonna collect, I want you to get one completely done today, data collected. If you do, get started on the other one. But what else do we need to measure that you don't have tool for?
Just the math.
Math. So I'm gonna get out a couple of balances, but be very careful with my balances, okay? Meter sticks, we've got one thing of meter sticks over here. I used to have two, but I didn't get it out because of the craziness that is going on right now. Here are the Forcer meters that I'm gonna let you guys use. And is that it? Is that all you need? So I'm gonna get out two balances. I'm gonna ask you to please be respectful and share the balances. Okay? So get out your notebooks. I would write that information down and go ahead and get started.
You gonna leave me?